The Sun, spinning on its axis, lies at the very core of our solar system, weighing about 330,000 times that of the Earth. Its radius is 109 times the radius of the Earth. The Sun mainly comprises of hydrogen and helium, while some of the heavier elements in the core are oxygen, carbon, neon, and iron. The Sun is referred to as a yellow dwarf, which is D-type main sequence star. All of us need the Sun's light and heat. If we don't get the light, the world is filled with darkness, and the producers on our planet will die, leaving us starving for food. If we don't get the heat, the planet will freeze us to death. The Sun's surface can get up to a scorching matter melting temperature of 5,778 Kelvin, and it's just the surface. The Sun's core, where the most amazing and delicate fusion reactions take place, the core can reach temperatures of 15 million Kelvin. It is the hottest temperature in our solar system. These insane temperatures can be explained by the enormous amounts of energy that the Sun releases every minute by a very delicate yet uncontrolled fusion reaction of two hydrogen atoms into one helium atom, which releases energy. The Sun's core fuses about 600 million tons of hydrogen into helium every second. This converts about 4 million tons of matter into energy. These high-density reactions cause huge explosions, and the sound of these reactions cannot travel to Earth, as sound cannot travel without a medium. The Sun was born approximately 4.6 billion years ago, when the solar system was dark and dense with huge amounts of matter spinning in a dense space, and the rest was a blessing of gravity. The Sun is our ultimate source of energy. As long as humanity lasts, the Sun will be the only source of energy that will be left after we would have used up every other resource of our planet. So will the Sun shine eternally? The answer is no. The Sun, just like other stars, will eventually run out of hydrogen atoms to fuse and will start fusing helium atoms into heavier elements. While you might have heard when stars die, they tear up the fabric of space-time, creating a black hole. This is true for most stars we know of. However, medium-sized stars, like our Sun, will turn into a much smaller star after it runs out of elements to fuse. Most stars fuse hydrogen atoms into helium in their cores. As a result, the energy that is released balances out with the force of gravity. This delicate balance is disrupted when the core becomes heavier due to the fusion of helium atoms into heavier elements. Our Sun too will start fusing helium into elements like carbon, making the star collapse on itself. Medium-sized stars like our Sun do not have enough core mass to form a black hole or a proton star. When the Sun expands, losing its hydrogen, it will become a red giant and will engulf Mercury and Venus while leaving the Earth uninhabitable. As this red giant further sheds its outer layers, Left behind will be a dense core, a white dwarf.